Good morning, everyone, to both sides of the world, to those in the Caribbean and to those in the Pacific. Allow me to say thank you for joining this Alliances for Action webinar to support the ACP countries and industries. I'm sure that you're used to seeing another face. I'm Tristan Alvarez. I'm with the Caribbean Agricultural Research and Development Institute, and I will be moderating for today. Now, please note that we have available interpretation into Spanish. You can select that by clicking on the icon below your screens. Today, the topic of the technical discussion on the webinar will be on coconut water production, processing, and value chain. This follows 4 other previous webinars that focus on other value-added commodity products. So today is the 5th, and we will close off this webinar series for this year with today's topic. Now, we have currently with us 140 participants who have registered from over 30 countries, so we thank you for being here with us. Despite the time difference, as I know it's a bit late in the Pacific, however, we are still grateful that you're able to join us today. So we will have a description of value-added coconut products targeting farmer cooperatives, micro, small, and medium-sized enterprises. Now, allow me to thank our donors and partners, especially the European Union, the CARIFORM Directorate, the Organization of African, Caribbean, and Pacific States, and of course, right here within the Caribbean region, all of our alliance partners, the Coconut Industry Board, Scientific Research Council, CELOS, etc. There's so numerous to name. With that, I'm very grateful that we're able to have the range of presenters before us this morning. So just before I invite the first speaker, allow me to make mention of Dr. Luna, who is from the Center for Agricultural Post-Harvest in Indonesia. She's one of their researchers. Mr. LAJAROJ, who is a food innovation engineering consultant out of Thailand. And we have also with us Dr. ANANDHARAMAKRISHNAN from the Indian Institute of Food Processing Technology. So once again, I want to thank the presenters formally for their service and for the sharing of their knowledge and expertise. And as I said, it's early evening, late evening in that part of the world. So of course, it's their time, and we're grateful for your being here to share that knowledge with us. We will also be hearing from Ms. Selfina from the International Coconut Community. She will share some words with us in closing by the end of today's session. With that, let me now introduce and bring to the fore the first speaker, Dr. Luna, to share with us her presentation. Once again, the topic of focus today is on coconut water production and processing and sustainable coconut water sector. Dr. Luna.
Okay, thank you, Tristan, for your nice introduction. Good morning, good afternoon, good evening, ladies and gentlemen, distinguished speakers, depending on where you are joining us from. I hope that everyone is in a good health. First of all, I would like to deliver my gratitude to Dr. Jelfina and the committee for inviting me to this webinar. And I'm very grateful to be able to share knowledge and information with you all. My name is Prima Luna. I'm a senior researcher at Indonesian Agency for Agricultural Research and Development. So let me share my presentation. Okay. Can you see my presentation?
Yes, we can.
Okay, yeah, thank you. So in this session, I would like to share information entitled Overview of Coconut Water Processing, Production, and Sustainable Value Chain. Ladies and gentlemen, we have already known that every part of a coconut tree can be useful and nutritious. That's why called coconut life, yeah. Coconut is a life tree, yeah, if I'm not mistaken. And then start from the nut until the flowers, we can take the benefits from them. And here is the industrial innovation tree. From the nut, we can obtain a healthy drink, and then or a sport drink, and then nata de coco, and then we can obtain as well the ketchup. And from the flowers, we can get the nectar or honey, and then tonic, pollen, vinegar, and all is we can obtain products and value-added products also very promising from the coconut tree. And then the characteristic of coconut water that we have to consider. We know that coconut water will lose almost all its unique organoleptic properties. And then after we extract it from the nut and start to fermenting, and coconut water will turn into turbid, yellowish, sour, and has bad aroma. This caused by the existence of oxidase enzymes, such as polyphenol oxidase and peroxidase, and also the microbe contaminants. So we have to ensure the elimination, the causes of its quality degradation using various methods to preserve the coconut water. And in this session, I would like to share the recent advances of the preservation technologies. Ladies and gentlemen, we know that coconut water has a food composition and relatively high in minerals, such as potassium, amino acid, and then hormones, beneficial bioactive compounds, such as vitamin C, vitamin B, and then protein as well. And coconut water also contains fat, around 0.2%. And the nutritional composition of coconut water varies with the maturity, the variety, location, and then soil condition and other environmental factors. And we also know that Food and Agricultural Organization has already established the specification for package for natural coconut water, as well as the technology that commercialized for the small manufacturing enterprises with the small scale production of bottled coconut water. And then usually in commercial production of coconut water, we use the cold preservation technology and the shelf life at least 10 days under the refrigerated conditions. So ladies and gentlemen, this is the recent advances in various technology for non-thermal processing and preservation method. We can see here for the thermal technology, we can use the conventional heating and the microwave and then ohmic heating as well. And the non-thermal technologies, we can use the UV and the high pressure processing or ozonation. So the mechanism is actually the same, is how to separate and how to separate the the microbes, how to lysis the microbes cell, and then also we can use the additives just to hinder the activity of enzymes and also the microbiology or microorganism. And the characteristic that we have to consider in the coconut water, first is the aroma or the flavor, total solid, and then acidity, turbidity, color, vitamins, and also minerals. And next. Okay. There are benefits and also drawbacks from the thermal and also non-thermal processing. For example, the conventional heating, the temperature we use usually above 85 degrees until 100 degrees with time moreover 10 minutes. It can preserve the coconut water up to 6 months. And effectively, it activates the enzymes. That's the main cause of the degradation of the quality of coconut water, and then also reduction in microbes, and then it will save the microbiology for the consumption till the 5th week of storage under the lower temperature. However, there are many drawbacks. For example, first is the slight decrease in acidity during storage, and then it will appear undesirable pink color, and then lost the desirable sweet sour flavor and development and astringent quality, conventional heating, and then the quality also lost. Some nutritional composition also lost during the heating. And however, for the non-thermal processing, for example, micro ultrafiltration, we can see here that it can reduce the E. coli and also Listeria monocytogenes. And for ultrafiltration, it can inhibit the enzymatic activity. Ozonation, we can see here it has a little or minimum changes in acidity, pH, and total soluble solids, and complete inactivation of polyphenol oxidase activity, and other combination with the ozonation also can prolong the shelf life of coconut water. However, the drawback is still we can need to store under refrigerated conditions. Here is some other method that we can use to prolong the shelf life of coconut water. By using the chemical preservatives and also additives, for example, treatment using the addition of ascorbic acid, and then also using the sodium metabisulfite, and then sodium hypochlorite. Also, this chemical preservative is based on literature. And then we can use the acetic acid, sodium metabisulfite as well. And also combine with other preservation, for example, microfiltration. So the benefit of this method, there is changes of the quality, nutritional composition, and also the sensory. However, it's only a slightly change. And then also it alleviates the browning problems in coconuts, and then sodium bisulfite reduce the discoloration and effectively controls the rancidity than acetic acid. And then it can extend the shelf life up to 46 days at low temperature storage condition. We can also use the Hardol technology. So this is the combination of preservation technology that we can apply in the coconut water production. For example, we can use the UV light treatment combined with the cinnamaldehyde, the chemical preservatives, and also we can put in a storage, a low temperature for the storage. And then it can inactivate the heat-resistant variants of E. coli, and also it can achieve a reduction goal for the most heat-resistant E. coli without altering the sensorial acceptability of coconut water. So this one is practical in the small industrial for coconut water. You can go for the YouTube, and then I think this one is very interesting. So you can apply in a small manufacturer for coconut water. Start from the washing the nut, and then extracting the water. Here we use the heater of pasteurization. And also aseptic bottled and put in the refrigeration. Okay, now this is also interesting. I think this one is very interesting. So we can drink the coconut from the nut itself, and the equipment will be easy to find. We can engineer the country. Maybe in my country we also have this type of machine. Okay, so I'm currently doing research in preservation technology for coconut water, but using the ozonation. Here we can see this is the illustration of using the ozonation technology. This is the ozone generator, so it's very not too big machine, and the price also, I think in my country is how to say, feasible for small enterprise to buy, or maybe to engineer the machine. It is like this, the machine for ozone generator, and then we have the tube here to connect to the coconut water and process. And also we have to provide this type of equipment to measure how much ozone in the process. Here we use the photometer equipment, and then after we do the ozonation process, we can go for sealing the package of the coconut water like this. And this is the type of product. So based on this research results, the coconut water, the pH and also the total solid dissolve remain stable until 2 weeks, and then still put in the refrigerator. So why we did this research? Because during the pandemic, I think the selling of coconut water increased because of the functional effect on human health. Yeah. So especially for in Indonesia, for the variety coconut Nucifera viridis, is we believe that based on previous research, it can increase the immunity, and then people how to say, buy the coconut water variant viridis. Maybe they drink every day just to get the functional beverage for this to increase the immunity. And ladies and gentlemen, maybe I would like to share, this is the national standard for the coconut water in Indonesia. So the parameters that we look for and we have to maintain is the color, the aroma, the taste, and then the pH, the total dissolved solid, the potassium, and then heavy metal contaminants, and also the microbial contaminants. So after we produce all the coconut water, and in the how to say, the nutrition fact of the products need to measure all these parameters. Just a brief downstream process that we have to consider as the small manufacturer. That we have to consider the value added of the raw products, of course, to get more income for the small enterprises, and we have to set what is the competitiveness of our product, and of course the customer satisfaction is our target. and we have to maintain the quality products of, for example, for products of coconut water. And product properties that we have to maintain is, of course, the physical-chemical, depend on the standard in your country, and then the nutrition, the functional, and then the food safety is very important, the residue, the contaminant, and also the traceability in terms of the efficiency process and also the supply chain. So I think all these points is very important for you to get the sustainable value chain for your products. In this case, for your coconut water products. Okay, maybe that's all my presentation. Thank you so much, and back to you, Tristan. Thank you.
Thank you very much, Dr. Luna, for such a presentation, very informative and interesting. Definitely, I can say for the region, you've touched on some areas of concern and interest for us. As we all know, coconut water is fairly susceptible and sensitive in terms of shelf life. And this is something that many persons have tried to work around. And of course, pasteurization is one of the more used methods in terms of extending shelf life. But for us here in the region, the CARICOM Caribbean region, we have a preference for fresh coconut water and unalterated taste and the thought and the quality of freshness behind that. But definitely you've put before us the different methods towards treating with that issue, thermal and non-thermal, and I'm sure that the participants are very interested in that regard. Now, in terms of the technology as well, I know this is another area that much of the participants within the region would have some interest in terms of where they could source such equipment, contacts for the suppliers, price information, not exactly your area, but I'm just making reference to it in terms of the interest of where some of the agro-processors in the region will lie. So of course, this is something that we hope to address in more detail on December 14th, where we would have that technical session, where we would have a more in-depth conversation in terms of questions and answers. In that regard, let me now proceed with the second presenter for today. And this takes me now to Mr. LAJAROJ, a food innovation engineering consultant from Thailand. So it's a pleasure to have you here with us. And just following from Dr. Luna, we welcome you to the floor. Mr. LAJAROJ.
Okay. Let me share my screen. Okay. Can you see my screen now?
Yes, we can. Fantastic.
Okay. Okay. Let's start. I will introduce myself a bit. My name is KRIT LAJAROJ. Currently, I am a managing director of TSAT, Food Tech company located in Chiang Mai, Thailand. Now we are the technology supplier for the many novel processing for food and beverages, such as high pressure processing, radio frequency, microwave, pulse electric field, and many more novel technology. But for lab use and some for commercial scale. My topic today, we will talk about general typical coconut water processing method, and followed by normal pain point of the normal thermal process normally we use. The third is innovative new technology processing such as high pressure and pulse electric field and UV pasteurization that today all of the three processes is currently commercialized now. And some summary about the shelf life comparison of the three methods. We start from today. I think everybody know that coconut water is booming and still growing every year in sales and market. We see that in US, in Europe or China, it's a very big market today for coconut water. For general production process, normally we use thermal processing such as pasteurization, UST or retort sterilization. We see in the simple diagram here that it starts from cracking the nutshell, we collecting the coconut water, and suddenly after coming out from the shell, we have to cool it down to about 4 degrees Celsius to avoid the microbial growth. And then followed by the separator for filtration. And then in the big industry, we have to pasteurize it and maybe collect in the very big tank. So after that, we may use UST or sterilization again, and then filling in the clean process to the final package, such as aseptic paper box, for the very long shelf life, such as UST maybe 6 months or 1 year. We see here is a machine for pasteurization. Pasteurization, we have two sub-methods we call low temp long time that use only 60 to 75 degrees Celsius, but use 10 to 15 minutes for heating. And another pasteurize is HTST or high temp short time, that is quite a little bit higher temperature but very short time, that result in more good product quality, such as aroma taste, freshness will be better than low temp long time. We see the complex of the pasteurization in HTST method. Another widely used method is UST or ultra high temperature processing, that use about 135 degrees Celsius and very short time in just 3 or 5 seconds. UST is not only a heating process, but it involves we call aseptic method, such as the aseptic tank that strictly very clean process, and aseptic filling machine that we fill the coconut water into the bottle in a very clean environment, that's in a clean room, that we have a filter in everything to filter out the bacteria inside the environment. Another widely used thermal process is retort sterilization. Retort use the temperature between more than 121 degrees Celsius. And because of retort heat the coconut water inside the totally packaging, such as we fill in glass bottle, so it used a very long time for the temperature distribution to occur in the bottle, and we have to confirm the uniformity of the process. So retort give very clean with almost all microbial or bacteria inside the product and package will be killed or destroyed by very high heat. The product will be have very long shelf life, such as more than 1 year, and we call it a shelf stable product that is very easy to keep. We can keep it in room temperature or in a very hot environment for very long time. But we have a very big disadvantage of this method, that is the taste, the quality of the coconut water will change so much. The freshness will very less, and so much change from the fresh coconut water. We see that thermal processing have really big pain points, that is flavor loss, acoustic taste, or color damage. And actually all the nutrients, vitamins, or functional enzyme or some functional substance in the coconut water will be, I think, almost destroyed by this thermal process. But typical all these thermal process have also have the advantage in terms of capital cost. It's very cheap. It is has been used for a long time, so technically or knowledge is almost ready in many countries and almost of the world. So we next looking for the innovative processing for coconut water. Okay, we have talked about that topic. We have high pressure processing, pulse electric field, and UV co-pasteurization. That all these three technologies now available for commercialization today. We will start from high pressure processing. High pressure processing that I have worked with this technology for more than 10 years. In the last 10 years, this is very expensive, but now it's going cheaper, much cheaper today. We see that the HPP process is easily divided into the first step is fresh raw material, and will be crushed or compressed to get the juice. We bottling it, and then the whole bottle will be placed inside the high pressure chamber, and high pressure chamber will compress all of the package or all of the bottle, and then kill the bacteria inside in a few minutes. And then after that, in step 4, the product come out is safe to drink, have a fresh taste for a long time. This picture shows the step of the HPP. First, the product will be placed in a basket and moved inside the pressure chamber, and then the machine use the cold water to fill in the chamber, such as about 5 to 10 degrees Celsius, and the pressure is built up to very high, about 5,000 or 6,000 bar, and the pressure will be held in about 3 to 5 minutes. Then the process finished. We will see the pressure chamber here is a very thick, strong metal chamber, and the hole at the center is the where we place the product inside. We see here the picture show we place the product bottle inside the basket, and the basket will be moved into the pressure chamber here. We can use only about normally 30 to 45% of the chamber volume, because we see here that it will be a void between the bottle that we cannot use all 100% of the chamber. About the HPP processing parameter, we have 3 main process parameters, that is pressure, temperature, and time. We see here the first, that is pressurizing. Pressurizing will bring the side effect of temperature rising a little bit. We see here in the process, if we start at 5 degrees Celsius, the temp will rise to about 23 degrees Celsius during the max pressure used at 600 megapascal or at the 6,000 bar. The overall the all cycle of the HPP will finish in about 9 to 10 minutes. Include the input and output of the product. Now we see this graph. In this graph, we call the regulation of Frylock reduction. That is the HPP target to achieve. We see here the three of the pathogen, E. coli, Salmonella, and Listeria. In the coconut water, the first pressure used is 400 megapascal. We see in this picture that it not achieve Frylock reduction. And then we increase the pressure to 500. The lock reduction become almost 6 lock reduction that pass the Frylock regulation. And next, we increase the pressure to 600 megapascal. So you see that the result about the same. So this means we can use only 500 megapascal for the processing of coconut water. Next, we see that HPP can be used not only for liquid products or such as coconut water. HPP now used in meat product, in vegetable, seafood, juice, and beverage. It's a big sector today. We see that the market forecast for today and in the future, the increasing of the HPP product market is fast growing. We see here is the HPP machine. This size is an industrial machine, about 200 liters. We see the component, the hydraulic station is a powerhouse of the machine. And we see here is a high pressure chamber sector. Is where we place the product inside for HPP pasteurization. Normally, the industrial machine is quite big and very heavy weight for this machine weight. estimated about 30 tons. This smaller model is a 65-liter machine. Capacity is about 200 kilograms per hour. We see another way. For the HPP coconut water product, I think it become very widely used today. Just in Thailand now, I think maybe about 10 brands that using HPP for coconut water, such as Beat, and we see here Taste Nirvana that normally almost export to US market. We see here another coconut product we call coconut snowball. Coconut snowball, we see the inside coconut flesh. It is peel off for easily drink the water and can eat the coconut flesh that easy, is ready to eat. Normally, the shelf life is very short, but with HPP, we can extend to about 60 days shelf life. Another product today, I think coconut water has been infused to many innovation products, such as cold brew coffee that is very popular today. That can be extend the shelf life to about 60 to 90 days with HPP. Okay, we finished with HPP, and next we move to pulse electric field. Pulse electric field is another non-thermal technology that can be commercially today. The theory or the heart of the theory is we call the electric field. Electric field is the physical field that is created between the metal plates that have the positive and negative charge particles. So between positive and negative, we call the electric field. If we put the bacteria cell between the electric field will pull away the ion inside the cell, such as in we call cytoplasm. We have many mineral or ion inside. The electric field will pull it apart in opposite direction, and this phenomenon will create the stress inside the cell membrane. And if the electric field is strong enough, the field will tear apart the cell wall or cell membrane, that leading to the cell death. That we so we can use this phenomenon to pasteurization. But this electric field will be occur in a pulse session. The pulse is a very short time, in a microsecond, so the process is generate very low heat. This is the detail of the membrane that the hole will be created if the electric field is strong enough, and the substance inside the cell will leak out and causing the cell death. General application we can use for fermentation, so that increase activity in low electric field strength. This will stimulate the bacteria activity. In extraction, we can increase the yield improvement, such as in oil extraction, such as in olive oil extraction, or can be used with coconut oil extraction also. And drying drying can be speed up by 30%. Pasteurization that the main topic we talk about here, and texture modifying for chip and snack products. We see here the picture of the PEF system for pasteurized liquid product. This system is from area technology in Germany. We see in the center is the PEF unit, and have to use with the aseptic filling, that is a filling machine inside the clean room. We see the back side of the machine. This is the product tank, inlet and outlet tank, and CAP system for cleaning the system. This is the PF chamber that we apply the very high strength of electric field. The product will flow in here, and we will pasteurize after passing through it. Quick summary about PF system is a continuous flow process, and the process time is quite higher than HPP, reaching about 50 to 60 degrees Celsius. And it is approved by US FDA and European Union. It can be used to produce shelf stable by using heat assistant. Shelf life of the product is comparable to HPP product, which is about 2 or 3 months for coconut water. Okay, we next move to UV pasteurization. Okay, we maybe know that UVC is the subtype of the UV spectrum that can destroy the DNA structure. So it can be, the bacteria can be killed without heat or very low heat. The wavelength of the UVC is about 100 to 280 nanometers, which is the lowest length for UV region. Highly absorbed by most material and not reflect. Most of the material such as mirror cannot reflect UV. Cannot seen by human eyes, and most absorbed by upper Earth atmosphere. So in everyday life in the sun, we will not have a UVC. UVC is normally used by drinking water production, but the typically UV system for drinking water cannot be used with cloudy liquid such as juice or clear liquid, but have sugar or mineral content such as coconut water. So we have the new design of the UV reactor we call Vortex turbulence here, that can be used with cloudy liquid. This example of the machine from Acetolase, Israel. So this machine is already tested with coconut water and give the very good result. This is a picture of the machine. This also the test that UV can achieve Frylock reduction. This data is tested with E. coli with coconut water. This table shows the 6-log reduction of the UV system that comparable to heat pasteurized. In summary, UV is very energy efficient, energy saving technology that may be as high as 70% less energy required than thermal pasteurization, and it US FDA approved I think more than 10 years ago, and able to kill spore at low temperature. UV is the lowest cost compared to autothermal pasteurization such as HPP or PEF. The limited of the technology is only it can be used for low viscosity liquid product. It cannot use with a thick liquid or the liquid with a pulp or with a high solid content. We see many methods, and we now see about the shelf life of the coconut water. We have many parameters that affect the shelf life, such as initial product microbial load, or your process cleanness is one important parameter. Another is residual product microbial load, is how we operate the pasteurizer or the HPP machine. If we use it incorrectly, it will not give you the result of the Frylock reduction. Enzyme activity is one of the property of your product that we have to inactivate the enzyme. Or another is dissolved oxygen that can oxidation your product during the storage. And the packaging properties such as oxygen penetration or light penetration that can degrade coconut water during the long time of the storage. In comparison, fresh and processed coconut water, we may get the shelf life 3 or 4 days. If we use heat pasteurized, it's longer to about 21 days, or UHT to 12 months. With non-thermal high pressure processing will give us about 2 or 3 months in refrigerated condition at 4 degrees Celsius. It's the same as PEF will give comparable to HPP. UV pasteurized is the lowest cost, cheap, very cheap machine, but will give about 21 to 30 days with coconut water that I have tasted before. So the last, I think everyone may think about, so which technology is the right for your product? We have many methods. I think we cannot say the single one right answer, because I think we have so many situations of your business, such as how about your positioning in the market, such as premium, or you would like to sell the product at low price to, or you can think about how much you can invest in the machine cost. So I think we have not a single right question. Okay, it's finished for me today. I think if you have the question, you can email me later. I will reply you one by one by email. Thank you very much.
Thank you very much, Mr. LAJAROJ. A very interesting and educational presentation. I particularly appreciate how you close in reminding us that the choice of technology or the choice of process is really dependent on a number of factors, market consideration or market positioning being one of them. And of course, what's your investment cost options as well. Those are some critical points for us to be aware of in terms of what technology do we adopt. And just to follow on from Dr. Luna, she also reminded us in terms of standards. And right here within the region, we do have a coconut packaged natural water standard that has been approved within the region. This standard is to be adopted at the national level. It's voluntary, but the regional packaged natural coconut water standard exists, and you could obtain that information from CROSQ, the CARICOM Regional Organization for Quality and Standards. There's a code of practice as well as a technical specification which speaks to packaged natural coconut water. And it will be interesting to see whether or not some of these processes fall within or fall in line with what the specifications denote for packaged natural coconut water. As I indicated earlier, there's a preference within the Caribbean for fresh coconut water, unadulterated, but other markets are different in terms of pasteurized coconut water. Nonetheless, I have had the opportunity to peruse the participant listing. We are at 86 participants currently, so thank you for being here with us. And I also know that we have some agro-processors in terms of coconut water with us, and also some regional institutions. So thank you for being here with us on this very important topic of coconut water production, processing, and a sustainable coconut water sector. And thank you again, Mr. LAJAROJ, for explaining and bringing to us the different and the wide range of processes when it comes to the processing of coconut water. Now, with that, it's a nice segue into our next presenter, Dr. ANANDHARAMAKRISHNAN, who is the director from the Indian Institute of Food Processing Technology, based out of India. It's our distinct pleasure to have him here with us today, and I invite him now to take the floor and make his presentation. So Dr. ANANDHARAMAKRISHNAN, the floor is yours. Thank you.
Thank you so much. I'll share my presentation. And almost my earlier presenters explained about most of the technologies. It's made me like a simpler to go for other than the technology oriented and sustainable coconut water value chain. That's what today I'm going to talk about. All of you well aware of that. What is the health benefit of coconut itself is improve the glycemic conditions. It can be used one of the rare disease like reverse fatty, like a fatty liver disease, and a good antioxidant and very good potential of memory enhancer. And we know that 55 million tons of the coconut is produced annually, and various product has been available from, we discussed the coconut water, desiccated coconut, coconut chips is moving for fast movement, coconut milk, cream, coconut oil, and all other product, including the coconut sugar. And if you look at the total global market potential of the coconut product is continuously is a growing market, and 2020 is almost estimated 14 billion. It's going to be 29 billion in 2026, and most of this comes under the high demand area of America as well as Europe and the other regions of the Russia and China, and other like a lower side is African countries is coming, and slowly it's picking the market, and that medium Southeast Asia and Pacific it is continuously growing, and total market growth itself is at 12.5%. If come to the coconut water value chain, what are the sustainable value chain? If you wanted to look at, one is the raw material. Second one is the processing and preservation. That is the key element here, because the coconut water is a very, very perishable commodity. 2 to 3 days only is the shelf life. So we need to select the proper processing conditions as well as the preservation if you want to add, and packaging. Then market potential and then regulations. Each country has the different regulatory bodies, and consumer preference is coming. Demand is continuously increasing on the coconut water, and how to meet out that consumer preference on the coconut. We'll go and see one by one. Raw material is coconut productions. Globally, it is Indonesia is the #1 in the coconut production. Second is the Philippines, and third is the India, and almost Indonesia rank 1. And India is almost produced like compared to last year, it is 1.1% increased, and even Sri Lanka is increased 1.3%, and other countries, Brazil and Mexico and all, Thailand and Malaysia also is a sizable number of the production with respect to the area available. And look at the coconut products in the market, food, beverages, cosmetic, and others. And beverages and cosmetic is a very, very high demand. The growth rate is almost 14%. You look at the beverages, is the where is the coconut water is coming. The second slide, 2018 and 26. Among all the products, for example, dried coconut, coconut milk, and coconut oil. Coconut water jump that what is the current and the projection is more than 5 times jump the growth is predicted. That is the what is the fascinated to work on this one, and more people are coming forward to start their company, and it's really is going to be a good profitable company. Even a small entrepreneur or micro entrepreneurs or the farmers or the self-help groups one wanted to start that business. This is the ideal business. You can look at this clearly demonstrated where we can get into that. And the coconut is sold in the bottled fresh bottle. You can collect and keep it, and the treated bottle, the PET bottle, and bottling, and the all the way it is the good source of nutrient, antioxidant, and really can be used for the natural beverages. And if you see the comparison between the what people used to call as a sports drink, one of the drink is widely used in the Europe countries. Sports drinks is a artificial drink. Compare with that and our coconut water milligram per 100 ml. Carbohydrate is a 4,710 and there is a 5,800. But calcium is a high amount of the natural calcium is present in the coconut water rather than the milk. And look at the 27 milligram in 100 ml. And then potassium, already FAO is approved for the natural treatment of the increasing this potassium 204, and compared to sports drink is only 8. And magnesium, most of the electrolytes are present in the coconut water. That's what people wanted to move into this. And but big clutch is that how to preserve and how to treat this one for the longer shelf life. That's what processing and preservation comes in the value chain, and how to do that. And already explained by our previous speakers is one of the very, very highly sensitive to microbial attack. That's what 1 or 2 days loss of nutritional, and it's a bad smell, or the smell is comes automatically after enzymatic reaction starts PPO or PPOD, and how to control this enzyme activity in the system. That is the great challenge. That's what we have to select a particular equipment, particular processing, and then packaging to deliver to the consumers. And the very heat sensitive bioactive compounds also present into that. That's what we discussed just before the non-thermal processing. So the selection of the processing and the selection of the packaging and the selection of which is the raw material you are going to use, the matured one, and which is the one coconut water you are going to use. This is the water total coconut water preservation. If you see that one is the machine normally they used to do, and sodium sulfate. This is the biological preservatives add into that increase the shelf life. If you are not adding the addition of this biological or the chemical compound, we have the other ways like different type of processing conditions like pasteurization, the sterilization, and the bottling, and you can do high temperature, short time, and the carbonation you can do chilled and frozen like after the cooling. So these are the conventional technologies are used to enhance the shelf life of the coconut water. But now people are trying to go for the alternative to this, because when you use this one and you have extended shelf life, but you are losing the flavor. That is the key element of the coconut water, and that flavor has to be retained. Then only you can feel it as the natural water it present into that. That's what alternative to non-thermal. So definitely protect the volatile compounds, the better quality is the naturally you can no waste at all, and increase the shelf life, and no chemical added to that, no thermal loss, and the profit to industry. But only thing is here is the industry is the capital investment. That is the what one, and the volume. What is that volume you wanted to operate? That it may not be feasible from the this non-thermal processing. Non-thermal processing varies from the high pressure processing, UV, pulse electric field, pulse light, cold plasma. One of the area is coming up and we can be used, but irradiation has been come under the non-thermal technology. But for the coconut water treatment, irradiation is not advisable because turbidity is coming out after the treatment. And if you look at the global non-thermal processing market itself, it's a very high in the, earlier I mentioned about the Western Europe and America and other places, medium in the or Asia Pacific. And if you look at the membrane filtration in this non-thermal processing, it's easy to cut off. You select the cutoff membrane and you can treat the coconut water and remove the pathogens and other things. Then you can extend the shelf life. This is the easiest method to do that and a simpler one. And just you need to change the membrane frequently. But apart from that, high pressure processing just now is explained by both the speakers, is an excellent techniques. But where is the problem is that you have the volume. The larger you increase the volume of processing volume, issue was that capital investment going very high, because when you operate a 100 to 800 megapascal, even that is a good alternative. You go for that much pressure with a shorter time of few seconds is equivalent to the pasteurizations, and is a well proven. It kills the salmonella and E. coli and extend the shelf life. Yes, fine, but 28 days we get the extended shelf life without altering anything else. But the issue was that capital investment. If you afford to do that, this is the ideal method for go that. Apart from that, HPP method is the ultrasonication. So this can be used combination with the earlier HPP method, and there is the produce the cavitation is inactivates the microbial enzymes and can be used, and we can go for the 14 to 18 days for the treatment of ultrasound or ultrasonication method for treating the coconut water. And cold plasma technique, this is the what a newer technology has been developed, and even we are working in our institute as well. Just you create the species when you put the electrodes on both the side, and maybe more than 15 to 17 kilowatts of the power, ionize the gas. These free radicals go and kills that enzymes and inactivates the enzymes. So that's what we can reduce that Frylock reduction in the pathogens, and it's possible to do that and extend the shelf life to 48 days. And it's a good treatment, but we need to have some clarity on that. What happened to residual ions present in the coconut water? That also we have to be careful on selecting the exposure time and holding time for the how much power you have to keep it. All these things, if you alter it, yes, fine. Cold plasma also can go for the long way to treat the coconut water. Pulse light and pulse electric field, both are is a good for the treatment of that. For example, I have shown that figure as the pulse light, just exposed to that light, and it can be disturb the DNA structures and the damage the DNA structures, they extend the shelf life of coconut water. Other way around, the pulse electric field also can be used to treat the coconut water, and we can go for even the these studies has been shown 120 days storage at the room temperature. It was produced by the pulse electric field, and pulse light also has been given very good output, like a reduction of log reduction of 5.3. That's a good output of only for the pulse light. And other technologies also available. For the first speaker explained about ozonization is the another technology. You generate the ozone, and you can do, because ozone is already used for the water treatment and irradiation. I mentioned about some issues, and the carbonation can be give the perception, and people will enjoy taking that carbonation. All we like to have such type of things, and hurdle technology, acoustic field, and combination with the other technologies. And these are the technologies as the what we have to select based on what is that your customers, which is the place what they wanted from the product from you, and the capital investment. High pressure processing, high capital investment. Ultraviolet like a UV, it's not having much input on this one. And membrane processing, it has the own disadvantage and advantages. So that is the, you have to select the equipment or the processing condition, then it's possible to reach out the market where you wanted to go that. And if you look at the market potential now, the main issue comes here is mostly comes from the international market. I said Indonesia, Philippines, and India is they produce the coconuts, and they are looking for the market in the other countries. So we need to rely on other countries, what the consumer preference as well as the regulations and how to pump your material into other countries. So that totally depends on the other countries. Second, quality control problems and how to most of the microbial loads and everything throughout the storage period, everything we need to monitor like a blockchain mechanisms or something like that. We need to do that, and the lack of technical knowledge and even selection of the equipment itself, you need a good knowledge to select, and lot of which is the packaging material, Tetra Pak or can or bottle, which is the one. So which is the one suits for that particular country and particular shelves. So that's what we need to select. And see that what total market potential is. The growth rate is phenomenal from the 6.81 billion by 2027. That's what is a predicted. 18% growth rate is the wonderful growth rate. And how we are going to capitalize. That is the what the entrepreneurs from your country and who are watching these sessions, they should understand, yes, this is the what production is happening, and who are making the coconut oil or desiccated coconut, this water is become a waste there. So how to convert this waste into such a valuable product, and the market already is taking care about this coconut water. The one example I wanted to give, green tea. 10 years, 15 years back, green tea was not that famous among the consumers. Now you see the green tea market is a huge market, and people are predicting coconut water is go all the way like that what green tea has done. And the green tea market potential, you can see the Eastern Europe and Australia, North America, Western Europe. So coconut water has the place to capture such type of market. That's what I wanted to say from here. And these are the players like PepsiCo, Marico in India. They are doing the very big role into that gargle, and most of the big players already producing the coconut water. And we need to see that how to make it this product available in the other new market as well. And the potential driving force is the mainly is for the what is the selling point. It's the best rehydration drink and excellent source of the vitamins, minerals, calcium, everything is present what I mentioned about earlier on comparison that. And it's a healthy substitute. Now people after this COVID, everybody wanted to go for the healthy oriented products. So this is the ideal choice. And among the delivery through the different packaging like a PET bottle or Tetra Pak and cans, and 62% people are major share is comes for the wanted from the Tetra Pak segment. So that investment again is goes for the higher. So one can have that clarity on that, which is the packaging you are adding into the coconut water delivery system. So Tetra Pak means that investment also one should take care about producing the product. And the market scenario, South America and Asia reportedly is 90% of the coconut world consumption coconut water is going there. But the European sales continuously is increasing, especially in the UK. They are really taking into the alternative to the sports drink. That's what that market is growing. 40% of the Europe UK supplies comes from the Thailand. And another one inside this coconut water is they wanted organic coconut water, because whatever is comes from the coconut, some of the countries, the pesticides residues is naturally present, because that lot of pesticides used for the producing the coconuts, increasing the yield. That case, that pesticides can go to the coconut water. So that one should have that clarity on that, keeping in the mind. That's what organic coconut water is increasing the demand in the most of the countries, going for the 15%. And some of the example I want to give that case studies, that Teja coconut is the one of the leaders. They themselves is climbing as a 5:1 versus the competitions. No sugar-free bottled coconut water and cold filter. They use the cold filtered method. There's some membrane filtration like that preserves all nutrients. This is the what they are claiming. Another company in India is a company started in 2014 and almost $200 million US they started, and then $2,000 million now is the total they raised into 2018, and more than 14 cities in India. This raw company is supplying the coconut water treated by the high pressure processing. That's what we would like to say. Yes, once even that newer technology when you adopt, so people has to drink as how they are drinking in the tender coconut itself. So that's what these companies pave the way to do that, and shelf life is extended to 6 months, and so really is a good drink. That's what we need to think in the other countries, and all the other entrepreneurs who wanted to start up companies can think about how to capitalize the newer market using the newer technologies. Come to the regulation and the consumer trends on the coconut water. And this is the simple HACCP formula, the good practice for the FAO has given for the bottled coconut water. Just you need to wash the coconut and the sterilizations, and the standard, the bottle has to be sterilized. And this is for the small entrepreneurs to do that. For larger industry, sterilization of the both bottled cap and bottles and hygienic environment, you have to maintain the good manufacturing practice, and the filtration. After the filtration, you have to store at 4-degree temperature. Immediately you have to fill, and then stored again 4-degree temperature for 3 to 4 hours, and the labeling. And this is the protocol has been laid down by the FAO, and we need to follow these protocols. And apart from that, quality standards are varied with the different countries. For example, Indonesia SNI standards and Indian standards for Indian entrepreneurs, and Philippines, PNS, and Malaysia and Thailand, they have their own standards you need to follow. Over and above, we have the international standard, international featured standards are the food safety standard system, FSSC 22,000 are global food safety initiative standards. This can be also used, and the ethically prepared certification also will help to have the good market presence of your product. For example, you need a certificate like Rainforest Alliance certificate that gives for the end to end is the used without fertilizers, organic farm, and US the organic certification or fair trade certification. Now people wanted to go for the ethically prepared, the product has the good presence. That's what you need, a certification of low carbon footprint. Whatever you try to have the certification, get such type of things important presence in your market. Product has the market value. And apart from that, is the recent statistics, 56% population in the US wanted to buy the high value added product, especially the super foods. That very clearly coconut water is present among the superfoods, the list including the green tea, hemp, chia, quinoa, even millet, turmeric. But how much this is the capitalize the market, that's what one should think. Definitely market potential is that we need to select the ideal matured coconut, or what is the conditions of that, what is the processing condition. So definitely we can reach out this one. And this is the gives another example of how to reach out the consumer preference. And they recently released the data from IFT, 2016 and 2016, 82% population wanted a clean and natural ingredient, now to increase to 86%. Second one is a surprising data, is a 24% people wanted if price is low, they wanted to go and buy, but now it's become 17%. And now everyone wanted a natural products and the recognizable ingredient. Here everything is a natural. So this is what the consumer trend totally shifting to the natural and pure, and even high price people wanted to buy your products. So definitely we can go for the coconut water, and the consumer preference is not like 100 years back we have taken for the energy food, and 50 years back for the nutrition. Now we wanted to take a food for soul, we wanted to enjoy, we had to get the good nutrition and novel product. And ethically food choice, a low carbon footprint, whatever it is, then brand trust, you create that your own brand. So definitely coconut water has the place in the market, and let's make hunger free and healthy world. Thank you so much for inviting me to share my thoughts.
Thank you very much, Dr. ANANDHARAMAKRISHNAN, specifically for broadening our perspective and horizon as it pertains to the coconut water industry. So not only touching on the technical aspects behind the extension of shelf life via the processing techniques, but also with a view towards market considerations, market requirements, consumer preferences, and the growth of the coconut water industry. So thank you very, very much for broadening our discussion and widening our horizons in that regard. So this has took us through all three presenters, Dr. Luna, Mr. LAJAROJ, and Dr. ANANDHARAMAKRISHNAN. So thank you once again. What we are going to have as next steps, we're going to open the floor for some brief questions from the participant group. And then we are going to have some closing remarks by Ms. Meralda from the International Coconut Community. Before we enter into our brief Q&A session, And I would just indicate the process is that you raise your hand and you will be invited to unmute, and you could then ask your questions relevant to the presenter of today. So please raise your hand as I just give us a brief synopsis of this morning's proceedings. So we would have had the presentations this morning, and they would have all spoken to or given us an overview of the exponential growth of the coconut water industry. We know that the coconut industry is one that is increasing in demand, and that there's a lot of economic value within that industry. Now, we know that coconut water processing is with a view towards the extension of shelf life. It's one of the major considerations given the short shelf life of fresh natural coconut water. And of course, this is a marketing consideration. It's also a market access consideration based on what standards countries require for entry of that particular commodity. And there's a very real-life application and case within the Caribbean where a particular company was not given market access because of when they tested that particular product, they didn't meet the relevant standard in terms of MRLs and that sort of thing. So as a result, they were denied market access for a time. Now, we've been given a range of different processing techniques and technologies that one could adopt. Of course, there are considerations behind it in terms of thermal, non-thermal, the addition of preservatives, etc. There are even packaging considerations, but of course, above all that are market considerations. What are the consumers demanding in terms of a coconut water product? Is it fresh, organic, natural? Are there considerations towards shelf life? So this is also considerations, but also for the processor and investor, there are capital investment costs, there are production volume costs, and there are other considerations that really belie the overall investment to be made. So with a view to that, we want to thank the presenters for enlightening us, for giving us adequate knowledge in that regard. And we really want to appreciate their time and energy given the time in that part of the world. I'm talking about Asia and Pacific, where it's late evening. So once again, thank you very much. So this will now take us into the Q&A session. I take note that there is a hand raised, and let me invite Ms. Shadeen Beckles to take the floor and to pose a question to the panel.
Hi, good day, everyone. Thank you, Mr. Alvarez, and thank you for all of the presenters. Your presentations were very interesting, and my question is based on the different processing or preservation methods that were outlined today. Has any research been done to determine if there is a difference in taste of coconut water depending on the type of processing method used?
So I believe this is an open question directed to all the presenters. So any presenter can feel free to respond in this regard. And just to reiterate the question, whether or not there has been any work done as it pertains to a change in the organoleptic in terms of flavor, taste, etc. of coconut water based upon the type of processing technique or technology used.
Yeah, some studies have already done in the organoleptic properties, including the taste and color. Especially, for example, if you go for the high pressure processing, it changes bit taste and color, because you know that coconut water, most of the contents are salty, and you applying such a pressure or the heat treatment, we used to see that the taste changes, but we need to have the standard conditions like what we used to do the sensory evaluations or the sensory panelists. There only they optimize which is the holding time. Most of the time, the color and taste only they used to find out, but our reports are there. For example, some of the studies entirely changes the taste, so we can't go for the such type of technology. One is that ozone, the madam can explain some of the things. If you put it that you can get that residual taste comes out if you are not removing the totally oxidation as out from the after treatment or holding time. So it has been there, reports are there.
Thank you very much, Dr. ANANDHARAMAKRISHNAN. Of course, within the region, I'm aware that some agro-processors, they flash freeze their coconut water products to ensure the extension of shelf life, but also to maintain those properties of flavor, color, taste, etc. But Ms. Beckers, I trust that that has answered your question. I note that in the chat, there is another question, one from Ms. Beverly Alexander. She says, good morning, I'm from the Caribbean. How can I add value to coconut water? So once again, it's an open question to all of the panel members. How can I add value to coconut water?
Tristan, I would like to answer the question.
Sure, please. Go ahead.
Okay, thank you. From Beverly. So in my opinion, we can add the value from the coconut water by produce another product, for example, nata de coco. Hopefully you have heard that products, especially coconut water from the old nut, but from the 9 or maybe 10 months of nut, you can produce the fresh coconut water by method or preservation method that you can that the presenters or from my presentation also already mentioned about that. But for the old nut, for the coconut water, you can generate another product, for example, like nata de coco. Maybe that is my question, my answer. Thank you.
Thank you very much, Dr. Luna, for that response. I trust that it was well received. And just outside of the question, coconut water extends beyond just the fresh consumption. It's also used as a base in other beverages as a flavor enhancer and also to augment a range of beverage products in that regard. So that's also something to keep in mind as we speak about the broader coconut water industry as well. I note another question in the chat, and this question is there any information available about the global coconut market since years 2010 to 2021? And this is for all coconut products, but of course we are focusing on coconut water, so I'll just highlight that. But if there is any response from the panel in this regard.
He's asking from the 2020, but we have the data to 2010 data, like 14 billion was there 2020, and it is going to be like 29 billion US dollar in 2026. The annual combined growth rate is going to be 14.3%. The global market growth 12% annually. So that's what it is, like a 14 to 29 is a huge jump. What is the predicted from the 20 to 26 itself, another 5 years time.
Thank you very much. And of course, a number of companies have done a lot of market research, most of which you have to pay for online. But of course, these are also facilities which one could access. And of course, let's not forget the international coconut community, who may also be able to help in this regard. Now, there's another question in the chat. It's not specific to coconut water, but I will pose this just as a general question. And they are asking about are there any regional or international sources of seedlings? I'm talking here about coconut seedlings. And what would be the largest source for about 10,000 seedlings? This comes from Mr. Thomas, who I gather is from the Caribbean. So this may not be a question for the panel per se, but let me see if I could address it as such. Of course, we know that the availability of coconut planting material is a global issue, one that has drawn the attention of every major operator within the coconut industry. Within the Caribbean, there are some countries that can procure coconut seed nuts from third countries. So for example, sources can be from Costa Rica, Brazil, right here within the Caribbean. Guyana could also be a source of planting material in terms of seed nuts. And outside of that, another way that one could procure planting material is via tissue culture. And that is predominantly done through Mexico via CC. So there are sources of plant material within the region. It depends really on what the SPS and quarantine requirements are within your own country as it pertains to the importation of coconut planting material. That would really determine your source and type of material to be imported. But there is a shortage of planting material worldwide. So in terms of quantum, this is something to also keep in mind. Now, as I await further questions, either in the chat or in the participant listing by a show of hands, let me also indicate that on December 14th, there will be another session. This will be a technical session where you can pose your technical questions. So if it is you need some time to really think about your questions as it pertains to the presentation today, you can document those and have them ready for next week, Tuesday, December 14th, where we'll have a technical session where we really go more in depth in terms of addressing some of those. Of course, we will appreciate if you could submit those questions beforehand. So if there's any relevant research needed, that could be done and the information be provided to you. Now, there's another question in the chat, and just quickly, regarding freezing, which is a known safe practice, and especially in shipping. Has anyone come across clouding when thawed and during the 14 to 21 chilled holding time? And also, does freezing affect the taste of the coconut water product? So let me repeat that again. So regarding freezing, which is a known safe practice, and especially in shipping, has anyone come across clouding of the coconut water when thawed and during the 14 to 21 chilled holding time? And does the freezing process affect the taste of the coconut water? So once again, this is an open question to the panel.
My opinion, freezing is not a very good choice. So two issues, taste will change one. Second one is that possibility to again regrowth of the microorganism. That's what most of the places freezing is not the ideal choice to go with.
Thank you very much. So I trust that would have answered your question, Mr. Mohammed. So with that, I am not seeing any additional questions in the chat, nor am I seeing any raised hands. Let me indicate that the PowerPoint presentations are available via the link in the chat. That link will be reshared for anyone who has joined late. And also, this webinar is being recorded and can be accessible via the KRIT YouTube page. That link is also shared and will be reshared in the chat as well so that you will have access to it. Now, with that said, let me invite Ms. Merolda from the International Coconut Community. She is the Deputy Director, and she is going to share with us some closing words, some closing remarks as we seek to end today's webinar. So, Dr. Merolda.
Thank you, Tristan. Respected Chief Resource Speakers of the day, Dr. ANANDHARAMAKRISHNAN, Dr. Prime Luna, Mr. KRIT LAJAROJ, Thank you very much for joining this webinar. And this is the 5th of the series of the webinar, International Coconut Community, organized with the International Trade Center. And this is the last one of the series. We have organized 5 webinars, and this one is the 5th webinar we organized. And in this regard, ICC would like to thank International Trade Center and the other partner organization, that is European Union, KRIT Forum, KRIT, and other alliances, and Coconut Industry Board Jamaica for supporting this webinar. And in this today's webinar, all the speakers have very clearly explained about the coconut water, its market, different processing technology, and shelf life. As Dr. ANANDHARAMAKRISHNAN has rightly pointed out, coconut water is, though it is a very purest natural drink available in the planet, but this is very perishable also. So when we have to go into this business, we have to be very careful about its shelf life and its technology, especially so that we can keep the taste of the coconut water as such is natural taste. And I think the participants from the Caribbean who have attended today's webinar, they could know more about the coconut water, its technology, and the shelf life of the product. And I hope this webinar will be helpful them to think about going for a processing unit in the Caribbean, though it is in a small scale. And this webinar will be very helpful for them. And on 14th, we are going to have the technical session exclusively for the 4th webinar we organized on coconut milk and cream, and for this coconut water. So all the participants are requested, they can post their questions if any well in advance also, so that the resource speakers can be well attended their queries and all. So once again, thanks to all the speakers and International Trade Center for collaborating this webinar. Thank you.
All right, thank you very much, Dr. Medula. Now, let me once again express my appreciation to the presenters as well. Thank you for a job well done. Look forward to interacting.
Mr. Tristan, one hand is raised by Mr. Vincent Johnson.
Yes. Mr. Johnson, is there something you'd like to share with us quickly?
Vincent? Vincent, are you there?
Okay, so we'll seek to obtain a one-on-one interaction. Mr. Johnson is saying that he can't unmute. So Mr. Johnson, feel free to place a message in the chat and we'll relay that to the wider participant list. And while that is being done, let me invite the participants to partake in this poll. It is now on your screen, so please engage us in responding to this feedback poll. While that is being done, and while Mr. Vincent places his comment in the chat, let me extend my appreciation once again to all of the presenters. Thank you once again for your time, your effort, your knowledge, and your expertise, and sharing that with not only the Asia Pacific region, but the wider ACP group of states. It's really endearing to know your commitment to the world in this regard. Now, let me also extend and express appreciation to our donors and supporters, this being the European Union, especially for their support to the 11th EDF Fund, the CARIFORM Secretariat, the CARICOM Secretariat, and also the ACP governing body. Let me also express appreciation to our Alliance for Action partners within the region. So, of course, the International Trade Center, KRIT, who's also co-implementing a coconut project within the region, all the other alliance partners, Coconut Industry Board, Scientific Research Council, Silos based in Suriname, amongst many others. Of course, we thank you, the participants, for being here with us. A reminder once again that we will have a technical session on December 14th, where you'll be able to detail and pose all of your questions. Please feel free to submit those beforehand so we could prepare in terms of responses for the vast questions that we will receive. We will be grateful for seeing. And also note that the recorded webinar, today's recorded webinar, as well as the previous 4, are accessible on KRIT's YouTube page. The link will be reshared in the chat, as well as the presentations. They are also shared in the chat via a link that will be made available. Now, revisiting Mr. Johnson's questions, he's asking whether or not ICC and ITC can provide access to all webinar presentations. Yes, you would have registered, all participants would have registered, and we trust that we have your email addresses. So we can send out a mass email just indicating where all of that information can be found via the accessible and relevant links. So that can be done definitely. So thank you very much. In terms of the poll results, just for your information. So we thank you for your participation. We thank you for your time. And once again, we know that we are living in a time where COVID is still amongst us. So we ask that you do keep safe, that you follow all of the relevant health protocols wherever you are from, and that we will look forward to seeing you when next we have another Alliance for Action webinar series. So thank you very much. Thank you to the international coconut community, and thank you to you, the participants, once again. Have a good day, everyone, and be safe.
Thank you. Thank you.
Thank you. See you all.
Thank you so much, everyone. Thank you.
Thank you.
Thank you.
Thank
Thanks,
you.
everyone. Bye.
Thank you. Take care, everyone.
Thank you very much.
Thank you.
Thank
Thank you. Awesome session, ITU.